Good morning, students. From today we shall start Unit 2. So Unit 2 is of DC and AC bridges. So why these bridges are used? What is a bridge first of all? So bridge is nothing but it is a combination of electrical components which form a loop. So these bridges are of two types. These bridges are of two types. Why these bridges are used? So these bridges are used to solve a complex network and to balance the circuit. So here there are two types of bridges. Those are, one is AC bridge and the other one is DC bridge. So DC bridges and AC bridges. So this unit we shall completely discuss about the DC and AC bridges. So coming to the first one, DC bridge. So DC bridge, as the name itself we are saying DC. So there is DC means we need to use the DC supply. So if you observe here, the supply used here is DC supply. So here the supply used is DC supply. So this DC supply is given to the bridge circuit. So this bridge, usually a bridge will consist of 4 arms. There will be 4 arms. So these 4 arms are in a loop structure. They are formed in a loop structure. So here R1, R2, R3, R4. So these 4 arms are formed in a loop structure and this is given to the DC supply. And this is given to the DC supply. So this is called DC bridge. So in between two resistors, two nodes, we can say two nodes, there will be a DC supply and the remaining 2 arms there will be galvanometer. So why this galvanometer is used? So this galvanometer is used in order to balance the circuit. So for a DC bridge there will be four branches, that is four resistors, and here we are saying while using DC bridges you will be using only the resistors, and while coming to the AC bridges you will be using the impedances. You need to consider the impedances. You should not say only resistor. So here in the DC bridge there will be DC supply and the galvanometer is used to balance the bridge, is used to denote the balance of the bridge. And next, coming to the AC bridges, in the AC bridges the only difference is the supply is used here is AC supply and the impedances here you are considering in place of resistors, you can consider the impedances. So you can notice here Z1 is placed in place of R1, Z2 is placed in place of R2, Z3 is placed in place of R3 and Z4 is placed in place of R4. And also here in place of the galvanometer for AC bridges you should use the detector here. This detector can be vibration galvanometer or headphones or something, etc. So for DC bridges the differences are you will be having DC supply and here you will be having the resistors and here you will be having the galvanometer. So for AC supply will be AC bridges, supply will be AC and here you will be using the impedances and here you will be using the detector. Okay, this is the major differences. Now coming to the basic AC bridge equation. So what is this basic AC bridge equation? So here this bridge consists of 4 arms as I told you, Z1, Z2, Z3, Z4, and in between the 2 nodes there will be a detector and the other remaining 2 branches there will be supply. And next here you notice here E is the total voltage applied here and the current is in the first branch it is I1 and in Z2 the current is I2 and in Z3 it is I3 and in Z4 it is I4 and across Z1 the voltage is E1 and across Z2 the voltage is E2 and Z3, E3, Z4, E4 respectively. Now we shall solve the equation. We shall solve this bridge by using simple nodal equations. You can consider here the total current is, the total voltage applied is E and this E is applied to the total branch, and here the current is getting divided into I1 and I2. I1 and I2, and for the bridge to be balanced, here the I1 should be equal to I3. That means the current coming through Z1 should completely flow through the Z2. That means this I1 should be equal to I3, as well as this I2 which is flowing through Z2 should completely flow through Z4, that is I4. So there should not be any current flowing through the detector. There should not be any current flowing through the detector. So to make the current to be zero, what is the condition here? So that means E1 should be equal to E2. E1 should be equal to E2. So as I told you, for the bridge to be balanced, the current through the detector must be 0. That requires the potential difference VBD to be 0. So to make that VBD 0, that VAB is equal to VAD. So that means the voltage across Z1 is equal to voltage across Z2. So that means E1 is equal to E2. So what is voltage? Voltage is nothing but current into resistance. So according to, if you apply Ohm's law, so E1 means current into resistance or impedance, we can say. I1 into Z1, that is equal to I2 into Z2. And next at balance, so at balance I1 Z1 is equal to I2 Z2, and also as I told you, I1 should be equal to I3 and I2 should be equal to I4. So I1 is equal to I3 is equal to, current is nothing but voltage divided by resistance. So voltage here is, total voltage is E, and the complete impedance of that branch is Z1 plus Z3. Similarly, I2 is equal to I4 is equal to E divided by Z2 plus Z4. I2 is equal to I4 is equal to E divided by Z2 plus Z4. Now if you substitute this I1 and I2 in this equation, then you will be getting E by Z1 plus Z3 into Z1 is equal to E by Z2 plus Z4 into Z2. So then it becomes Z1 by Z1 plus Z3 is equal to Z2 by Z2 plus Z4. Now by solving cross multiplying, you will be getting Z1 into Z2 plus Z4 is equal to Z2 Z1 plus Z3. And next, hence by solving this above equation, you will be getting Z1 Z4 is equal to Z2 Z3. This is the very important condition for any AC bridge to be balanced. That is, the product of impedances on the two opposite arms is equal to the product of the remaining two arm impedances. The product of impedances of the opposite branches is equal to the product of the remaining impedances in the bridge circuit. That means Z1 Z4 is equal to Z2 Z3. So this is the basic equation of an AC bridge. So now let us consider impedance in polar form. So polar form, as you all know that what is polar form? Polar form is nothing but R at an angle theta, where R is the magnitude and theta is the phase angle. So here impedance in the polar form is equal to Z is equal to Z at an angle theta. Here Z is the magnitude and theta is the phase angle. So similarly you can write for Z1. So Z1, if you substitute, we know that Z1 Z4 is equal to Z2 Z3. So Z1 at an angle theta 1 into Z4 at an angle theta 4 is equal to Z2 at an angle theta 2 into Z3 at an angle theta 3. Now you solve this equation. How you can solve this equation is, always in polar form you should multiply the magnitudes and phase angles should be added. So this you all know that you have already studied in your previous classes. Not in this class, before in first year or in intermediate you have already studied. So that means polar form, always the magnitudes should be multiplied, whereas the phase angles should be added. So that means this becomes Z1 into Z4 at an angle theta 1 plus theta 4 is equal to Z2 Z3 at an angle theta 2 plus theta 3. That means for a bridge to be balanced, you need to balance the magnitudes and also the phase angles. That means Z1 Z4 is equal to Z2 Z3 and theta 1 plus theta 4 is equal to theta 2 plus theta 4. So that means the condition, this is the condition for magnitude, and the phase angle criteria is theta 1 plus theta 4 is equal to theta 2 plus theta 3. So for any bridge to be balanced, you need to equate the magnitudes, and also magnitude criteria should be satisfied, and also the phase angle criteria should also be satisfied. When both the conditions are satisfied only, then you can say that the bridge is balanced. If any one of the condition, suppose the magnitude is satisfied, magnitude criteria is satisfied, but the phase angle criteria is not satisfied, then what is the situation? Then you can say that the bridge is not balanced. So the bridge is balanced only when the magnitude condition is solved, and also the phase angle criteria is also equated. So then only you can say that the bridge is balanced. So this is the condition for any AC bridge whenever you are solving the bridges. So if you are considering any problems also, you need to look at both the situations. That is, when magnitude criteria and also the phase angle criteria should both the conditions should be satisfied. Now let us consider measurement of resistance. So why these bridges are used? So why these bridges are used is, you can calculate measure the resistance, inductance, capacitance or frequency, whatever it might be. So you can measure any one of the electrical parameters using these bridges. So in that, first criteria is measurement of resistance. So how you are going to measure the resistance? So under the measurement of resistance, there are three methods. Resistance is classified into three resistances. First one is low resistance, medium resistance and high resistance. So low resistance means whenever the resistance is less than 1 ohm. When the resistance is less than 1 ohm, then the resistance is called low resistance. When the resistance lies between 1 ohm and 100 kilo ohm, 1 ohm and 100 kilo ohm, then it is called medium resistance. When the resistance is greater than 100 kilo ohm, then it is called high resistance. So the resistance are classified into three types. One is low resistance, medium resistance and high resistance. So low resistance means the resistance which is less than 1 ohm, it is called low resistance. The resistance which lies between 1 ohm and 100 kilo ohms is called medium resistance, and the resistance greater than 100 kilo ohm is called high resistance. So for measurement of low resistance, there are several bridges, and for measuring medium resistance, there are other bridges, and high resistance also different bridges are there. So these bridges we will study one by one. So coming to the low resistance, measurement of low resistance. First topic, measurement of low resistance. The bridges which are used to measure low resistance are called ammeter voltmeter method, Kelvin's double bridge method, third one potentiometer method, and these three methods are used to measure the low resistance. In that, first one is ammeter voltmeter method. So in this ammeter voltmeter method, you can notify. Ammeter voltmeter method means the circuit should consist of an ammeter and also a voltmeter. In this ammeter voltmeter method, there should be voltmeter and an ammeter, and the resistance which you need to measure is marked as Rx. Here Rx is the resistance which you need to measure. Rx is the low resistance which you need to measure, and you can use a voltmeter and ammeter. So voltmeter will give you the voltage rating, and the ammeter will give you the current rating. So what is the resistance? Resistance is equal to the voltage divided by current will give you the resistance. Here, whenever this voltmeter comes first, then the resistance, this method will be used for the medium resistances. There will be losses in the voltmeter. So the current completely flows through the ammeter, so there will be losses for the ammeter and voltmeter. So here you can consider ammeter coming first and next voltmeter. So this ammeter will give you the current rating, whereas this current gets divided into voltmeter current and resistance current. So this voltmeter current can be neglected so that the total current will be flowing through the resistance. Now what is the resistance formula? Resistance is equal to the voltage divided by current. So voltmeter rating divided by current ammeter rating will give you the low resistance. So this is about the ammeter voltmeter method. Next one is Kelvin's double bridge method. So before going to the Kelvin's double bridge method, you need to know it, because Kelvin's double bridge method is a modification of Wheatstone bridge. So Wheatstone bridge first we shall let us study what is Wheatstone bridge. Later you can study the Kelvin's double bridge. So what is this Wheatstone bridge? So Wheatstone bridge you might have studied it in the earlier classes. What is Wheatstone bridge? So Wheatstone bridge consists of 4 arms. It consists of 4 arms. They are P, Q, the resistance is P, Q, R and S. Here P, Q are known resistances, R is the unknown resistance which you are going to measure, and S is the variable resistor. Here the total applied voltage is E. Capital E indicates the total applied voltage. Then here the current will be divided into two ones, one I1, I2, and this I1 will be going through the I3 and also galvanometer. As I told you, as I explained you earlier, now the bridge to be balanced, there will not be current through the galvanometer. There will not be any current flowing through the galvanometer. Then I1 will be equal to I3. So that here also I2 will be completely equal to I4. So now by solving this equation, as we know, what is the condition we have derived now? It is nothing but the opposite two branches product of opposite two resistances is equal to the product of the remaining two resistances. That means P into S is equal to R into Q. So that means R is equal to PS divided by Q. So this we have already studied, and also we can solve this by using the current equation, nodal equations, as we have derived in the last topic. So it works on the principle of null deflection. So null deflection means whenever the bridge is balanced, there will not be any current flowing through the galvanometer. Whenever the bridge is balanced, there will not be any current flowing through the galvanometer. That means the galvanometer will indicate null deflection. That is, it will not show any deflection. It will show zero deflection. So this works on the principle of null deflection. So null deflection, and the bridge is said to be balanced when there is no current through the galvanometer. So by applying the same condition, we can solve this equation. So I1P is equal to I2R, and that if the bridge to be balanced, then I1 is equal to same as the I3, that is equal to E by P plus Q, and I2 is equal to I4 is equal to E by R plus S. Substituting these values I1, I2 in this equation, then you will be getting P into E divided by P plus Q, R into E divided by R plus S. By solving that equations, you will be getting PS is equal to RS. This we have already studied. What is by seeing the bridge itself, you should be able to tell this condition. What is this condition? That is, the product of two opposite resistances is equal to the product of the remaining two branch resistances. That is, P into S is equal to R into Q. So that is R equal to P by Q into S. So that means from this equation you can know the R value. So R is nothing but the unknown resistance, and PQ are ratio arms. P by Q is the ratio arm. S is the variable resistance. S is the variable resistance. So by substituting all these values, you can find out the value of R. So in any problems also, you can remember this formula. Opposite branch resistances is equal to product of the remaining two opposite branch resistances. Then you can find out what is the unknown resistance in that equation. So as I told you, the value of unknown resistance is determined by the help of equation 3, where R is the unknown resistance, S is the standard arm, P by Q is the ratio arm. Okay, now here you are having only one ratio arm, whereas this Wheatstone bridge is used to measure the medium resistances. So it is used to measure the medium resistances. For low resistance, while measuring the low resistance will be having 4 terminals. In order that the lead terminals are also calculated, are also used. Here, while that lead resistance should be also be considered in the circuit. For that purpose, you are using double bridge. Double bridge means double indicates 2. So that means there will be 2 ratio arms here. So Kelvin's double bridge will be having 2 ratio arms. So it consists of 2 ratio arms. P and Q is the first ratio arm. Capital P and capital Q is the first ratio arm, and small p and small q is the second ratio arm. So if you observe in this diagram, capital P, capital Q is the first ratio arm, small p, small q is the second ratio arm, and small r is this is the lead resistance. This is the lead resistance. So you need to solve this bridge. So this bridge will be balanced when the galvanometer indicates 0, when the galvanometer shows null deflection. So this null deflection will be observed only when the voltage VAB is equal to VAMD. Notice these points. A is the starting point, B, and this is the C. ABC is the outer ratio arm, and inner ratio arm is MDN. So MDN is the inner ratio arm. So the outer ratio arm is nothing but voltage is VAB is the first voltage. This voltage should be equal to the VAMD. So equating these voltages, you will be able to calculate the unknown resistance R. So that means this EAB is equal to EAMD. So what is this EAB? EAB is nothing but P by P plus Q into EAC. EAB is equal to P by P plus PQ into EAC. So the total voltage is EAC. And what is this EAC? EAC is nothing but this complete voltage. This complete resistance is capital R plus capital S. And here consider this triangle. These two resistors, small p, small q, are in series, and that one will be in parallel with the small r. So P plus Q parallel R. That means P plus Q into R divided by P plus Q plus R is the total resistance. So now the same you have substituted here. So EAC is nothing but the current I into R plus S plus P plus Q parallel R. So that means P plus Q into R divided by P plus Q plus R. So this is EAC. Now substitute this EAC value in this equation. That gives EAB is equal to P by P plus Q into this value. And what is this? This is EAMD. So EAMD is nothing but I into R plus P by P plus Q into P plus Q parallel R. So now EAC is equal to I into PR divided by P plus Q plus R. So now solving these two equations, you will be getting at zero deflection, as I told you, EAC is equal to EAMD. Substitute these two values in this equation, you will be getting the equation R is equal to P by Q into S plus PR, small pr by small p plus q plus r into the ratio arms P by Q minus small p by Q. So now if the ratio arm values, ratio arm is nothing but capital PQ is one ratio arm, small pq is the other ratio arm. If the ratio arms are equal, then there is no impact of the R, small r. What is this R? R is the lead resistance. So if these two are equal, then the second term will be completely equal to 0 and the equation will be same as the Wheatstone bridge. So Wheatstone bridge equation is R is equal to P divided by Q into S. So there will not be any impact of the lead resistance when both the ratio arms are equal. So when this is equal, then R is equal to P by Q into S. So this is the equation for the Kelvin's double bridge. And next one, potentiometer method. So potentiometer method is nothing but here. So potentiometer is used to measure the voltage, right? So potentiometer is used to measure the voltage. So here in this circuit, if you consider R is the unknown resistance which you need to measure. R is the small value of the unknown resistance which you need to measure. And S is the standard resistance which you know the value of the standard resistance. And here ammeter is used to measure the current flowing through the ammeter. And here you are using stabilized DC supply. Stabilized DC supply means the supply will be constant. Supply should be constant. It will not vary. There will not be any fluctuations in the supply voltage. So this stabilized DC supply is passed through the rheostat. Here this rheostat is used to vary the current flowing through the circuit, that is ammeter. So here first initially here if you observe double pole double throw switch is there. So that means here double pole means two poles are there and double switch means double pole double throw. That means in one throw it will go for one dash position, and in the other throw it will be going to the two dash position. So consider the switch is in the position 1 dash. So then what is the voltage here? So if it is given to the 1 dash position, then the potentiometer is getting connected to the unknown resistance. It will be connected to the unknown resistance. So that means it will show the voltage across this resistance. That means VR is measured. So VR is equal to I into the current in this branch is I into R will be the VR. And next, if the switch is moved to the position 2 dash, then the resistance is S, the voltage will be I into S. So in this position it is VR and voltage is VR, and in this position the voltage is Vs. Now consider the equation VR is equal to IR and Vs is equal to Is. Now divide these two equations. So that means VR divided by Vs is equal to IR divided by Is. This I gets cancelled. VR by Vs is equal to R by S. So R is equal to VR by Vs into S. So here VR will be calculated when it is connected to the potentiometer is connected to the position 1, and Vs is calculated when the potentiometer is connected to the resistance S. And S is already standard resistance value which is already known. So by knowing all these three values, you can calculate the value of the unknown resistance. Value of the unknown resistance capital R. So R is equal to VR by Vs into S. So this is about the potentiometer method. So here for measuring the low resistance, as I told you, there are three methods. First one is Kelvin's double bridge method, second one is ammeter voltmeter method, and third one is potentiometer method. So these three methods are used to measure the low resistance. To measure the value of medium resistance, now let us see. Low resistance means the resistance which is less than 1 ohm is called low resistance. The resistance which lies between 1 ohm and 100 kilo ohms, it is called medium resistance, and the resistance lying above 100 kilo ohms is called high resistance. So for low resistance, measurement of low resistance, we have already seen the methods, and for the measurement of medium resistances. For the measurement of medium resistance, now let us see what are the different methods here. So those are ammeter voltmeter method, and second one is substitution method, third one is Wheatstone bridge. These three methods are used for the measurement of medium resistances. So in that first method, ammeter voltmeter method. which we have already studied in the measurement of low resistance. So in the low resistance we have studied, and there will be ammeter, voltmeter, and also voltmeter, ammeter also. Voltmeter comes first, whereas ammeter voltmeter method, ammeter comes first. So in both the things they will be getting the voltmeter reading and the ammeter reading. So the voltage divided by the current will give you the unknown resistances. So from this method you can calculate the resistance. And the third one is Wheatstone bridge method, which we have already studied. And the remaining only one method is substitution method, that I will be explaining you now. So what is the substitution method? As we know that substitution means replacing. You will be replacing one value. So here if you observe the circuit, you will be having the E is the DC supply, and this DC supply, the R is the regulating resistance, and A is the ammeter, and next there is a switch here. If the switch is positioned to 1, then it is will be connected in the circuit. If the switch is moved to position 2, the unknown resistance R is connected in the circuit, and I is the total current flowing in the circuit. So now when the switch is positioned to 1, suppose consider position 2, then the voltage will be indicated, the current will be indicated by the ammeter, and you can note so R is the unknown resistance and S is the standard variable resistance, A is the ammeter, R is the regulating resistance. Now we put the switch at position 1, then the R is connected, sorry, here it should be 2, the position 2, the R is connected in the circuit, the regulating resistance R is adjusted till the reading of the ammeter is chosen at a scale mark. Here the ammeter reading should be chosen such that it should be of low value, so that the losses will be reduced in the circuit. So by varying this resistance, you need to first of all set a value in the resistance, value in the ammeter. So if you set ammeter value to 1 ampere, the current should be same when it is moved to position 1 also. Suppose you have set it to 1 ampere, and next you are moving the switch position 2 to position 1. When you move to the position 1, then S is connected in the circuit. The resistance S is connected in the circuit. And now here when it is connected, then you need to make the ammeter reading such a way that the same current flows through the ammeter. Previously you have set it to the 1 ampere. Now also you make the varying the resistance, regulating resistance, you need to set it again to 1 ampere only. Again into 1 ampere only. Then S is nothing but standard resistance dial. So whatever resistance is indicated to make the current 1 ampere, the same resistance is nothing but the unknown resistance. That is, you are substituting a resistance. You are substituting a resistance S in place of R. So the value of S will indicate the resistance of R. So that is nothing but the substitution method. So that's what here we are saying. Now the S is adjusted till the reading of the ammeter is same as the R was in the circuit. So that means the setting of dial S is read. So that value, that value of S dial, S is nothing but the value of the unknown resistances. So this is nothing but the measurement of substitution. It's a measurement of resistance by substitution method. So in the measurement of medium resistance, there are 3 methods: ammeter voltmeter method, substitution method, Wheatstone bridge method. So this is about the measurement of medium resistance. In the next class, we shall study about the measurement of measurement of high resistance. So measurement of low resistance can be done by, what are the 3 methods? Ammeter voltmeter method, Kelvin's double bridge method, and the third one is, what is the third one? Remember, so those three are there are 3 methods for low resistance, and there are 3 methods for medium resistance, and there are again 3 methods for the high resistance also, that we will be studying in the next class. Okay, thank you.